Guess who it is? Fourth time in a row, Mr. Boothman. 3.4 exponential and logarithmic equations is what we're talking about today. I really like this section because I love solving equations, and hopefully my enthusiasm will rub off on you. So let's take a look first at exponential equations. There are three types of exponential equations, at least when we're trying to solve them, and those are equations with equal bases, equations with unequal bases, and then equations that are quadratic in nature is what we call it. So we'll talk about each of these types in turn before we move on to logarithmic equations. This section might be a little long. I'll try not to make it so, but we'll see how it goes. Equal bases is our first type, and we have 3 steps to solve this. First, we rewrite the problem using equal bases. Remember that if I have f of x equals b to the x, b is my base. I said way back in our first video that you needed to be able to think about the bases pretty easily and quickly, so hopefully you listened to me. F of x equals b to the x, so here my base is 3, here my base is 27. I want the same base. So I can rewrite 27 with a base of 3. If I do that, I'll have 3 to the 2x minus 5 equals 3. Now, what power do I need to raise 3 to get 27? That's 3 cubed. Please try to get comfortable with the first few powers of most of the whole numbers. So now, step 2, I can drop the bases, since they're the same, and then set the exponents equal to each other. So if I do that, right, because 3 to the 2x minus 5 equals 3 cubed. That means my exponents have to be equal since my bases are the same. So I have 2x minus 5 equals 3. My last step is to solve. So if I solve for x, I have 2x equals 8. I have x equals 4. All right. So x equals 4. I can check that, plug it back in, and I'll definitely get 3 to the 3rd power equals 27. So that's when I have equal bases. Let's try some examples here. I'm going to have you try, actually I'll do these both because they're a little tricky. So for A, I have base 4 and a base of 32. What can I get that's the same base? 2. I can rewrite 4 as 2 squared, and I can rewrite 32 as 2 to the 5th. 2 squared to the x minus 6 power. Remembering my exponent rules, my power rules, if I'm raising a power to another power, I am multiplying the powers together. So this is 2 to the 2 times x minus 6 power equals 2 to the 5th. I can drop my bases, set them equal to each other. 2x minus 12 equals 5. 2x equals 17. X equals 17 over 2. Remember, I keep telling you, you are in honors pre-calculus now. Your answers will not always be nice whole numbers. They will not always be nice proper fractions. This is our answer. X equals 17 over 2. And we can plug that in and check it if we need to, but rest assured that it is the correct answer. Let's take a look at B. Or do I want you to try this on your own? I think this is a good challenge problem, and I'll have you try this on your own, and then we can talk about it in class. But for now, in this video, we'll move on to our second type of exponential equation, and that's when we don't have equal bases. We have unequal bases. So how do we solve these? First step is to take the log, the common log or the natural log, either one is fine, of both sides. So here you see I have 5 and 18. There's no way I can get the same base on both sides, so I will need to take the log. I'll go ahead and take the natural log. I really like the natural log. And that's all I do to both sides. I don't have to change anything. And this is totally allowed. As long as I do something to both sides, I can do whatever I want. Next, my goal is to solve for x. Well, how do I solve for x? I need to simplify using my properties of logs. So this whole thing is an exponent, so I can move that out to the front of the log. Then I can divide both sides by the natural log of 5. Just remember, the natural log of 5 is just a number. I can divide if I need to. And then really my third step is just to solve for x. So this is 2x minus, or add 3 to both sides, so I'll have 2x equals the natural log of 18 over the natural log of 5 plus 3. Divide both sides by 2. The natural log of 18 over the natural log of 5 plus 3 all over 2. And then I can plug that into a calculator and get a decimal approximation. Just the same as all of these problems. So let's take a look at some examples. There are a few more examples here than we had in our first type. I will do the first one. So this is pretty straightforward. Take the natural log of both sides, move my x out in front, divide both sides. Again, I could get a decimal approximation for that if I want. I would like you to try B and C. I'm going to do D. This is a particularly challenging problem, so I love it. I'm looking forward to doing this again. First, I take the natural log. Both sides. And now I'm multiplying 4 times 1 plus 10 to the 5x power. If I'm multiplying, I can split that up into an addition. And now I can subtract the natural log of 4 from both sides. And now, over here on the right, on the left I still have the natural log of 1 plus 10 to the 5x power. On the right I have the natural log of 12 minus the natural log of 4. Subtracting, that means I can turn this into a division problem. So that's the natural log of 3. Now if I look at both sides, I have the natural log of this equals the natural log of this. So I can drop my logs. I need the 2 arguments to be the same. Sorry, I'm going to finish this up here. I need my 2 arguments to be the same. So I can drop my natural logs, rewrite it like this, and then solve for x. But here, x is in the exponent again. I have 5x in the exponent. I need to take the log again. Told you this was a fun problem. Bring down my exponent. All right, I'm sorry. I really do apologize, but I keep running out of room. So I can divide both sides by the natural log of 10, and then divide both sides by 5. And I can get a decimal approximation from my calculator if I need to. So that's it. Really fun. Now, I promise not all of them will have you do so many steps like that one did, but if you want to have some fun, I think you should definitely try some like these yourself. All right, let's talk about the third and final type of exponential equation, and those are exponential equations that are quadratic in nature. Quadratic in nature, that's a special term, and that is a way of saying I have something squared, that same something to the first power, and then a constant. Just like a quadratic equation. Except this isn't x squared and x to the first power. This is e to the 2x and e to the x. But it's quadratic in nature is what we call it. So that means I'll be able to solve this just like I solve quadratic equations. I factor. You see this factors very nicely. I'll have e to the x minus 3 times e to the x plus 2 equals 0. I solve for x. So e to the x equals 3. Take the natural log of both sides. And then over here, remember my properties of logs. This is just going to equal x equals the natural log of 3. Over here I have e to the x equals negative 2, so I have the natural log of e to the x equals the natural log of negative 2. Uh-oh, I see a problem. Hopefully you do too. My last step is to check my solutions. I have x equals the natural log of 3, that's not a problem, but x equals the natural log of negative 2. Can I have a negative number in my argument of a logarithm? I cannot. That will not exist. So my only solution here is x equals the natural log of 3. All right, let's take a look at some more factoring examples. Let's take a look at A. This factors very nicely again. Use your x method if you need to. And then set each one equal to 0, solve for x. Take the natural log of both sides. So x equals the natural log of 2, and x equals the natural log of 1. Natural log of 1, we said that the log of any base of 1 equals 0. So these are two solutions. Do these work? Absolutely. I don't see any problems with these. We don't end up with a negative number in our argument. No domain problems, so we're good. Go ahead and try B on your own, in the interest of making this video as short and simple as possible. And we are going to move on from exponential functions to solving logarithmic functions. These are pretty fun. So there are 4 steps here. I do apologize, should be a 4. My first step is to isolate logs on one side. I'm going to go ahead and write all the steps here so we can see before we get started. So isolate my logs on one side, convert my whole thing, my whole log, to exponential form. I'm going to solve for x. And then just like my exponential equations, I'm going to check my solutions. Remember, you cannot have a negative argument. Talking about logs, of course. I feel like most arguments are pretty negative out in the real world. So let's take a look at this example. We can follow step by step. I want to isolate my logs on one side. That's already done for me. Step 2 is to convert to exponential form. So 2 to the 5th power equals x plus 2. Solve for x. Well, 2 to the 5th power is just 32. And then I solve for x. Perfect. Then I need to check my solutions. So if I plug in 30 for x in my argument here, I'm going to have 32 as my argument. That's not a problem at all, so I'm good. I'm done. All right, let's run through some of these examples. I'm going to ask you to do a number of them. Whether you do or not, I guess, is your choice, but honors pre-calc kids, I do think that you have some pretty good self-discipline. My base here is e. So change this to exponential form. E to the 8 equals x. And I'm done. I'm solved for x. I can get a decimal approximation if I need to, but as I say over and over again in class, I really despise decimal approximations. I think we lose a lot of accuracy and clarity when we switch to them, so I'm going to leave it like this, but I will specify if I would like you to simplify and use a decimal. Go ahead and try B on your own. Let's take a look at C. Now we need to call in all of our learning so far this unit to be able to solve equations like this. And that's the whole point, that math builds on itself. So I have two logs added together. I'm going to switch that to multiplying. Remember, I can change this to a single log, multiplying the arguments together. Oops. No, boy. Equals 1. And then I can change this to exponential form. So my base here is 10. 10 to the first power equals x plus 2 times x minus 1. I'm going to go ahead and multiply that out. If you need to use box method, you can. So I know that this is x squared plus x minus 2. Now, I almost have a quadratic that I can solve, but I need this to equal 0. So I'm going to move my 10 to the 1 over to the left. I'm going to subtract, so I'll have 0 equals x squared plus x minus 12. I can factor that. Again, use your x if you need to. X minus 3 times x plus 4. So x equals 3 or negative 4. However, my last step is to check my solutions. I cannot have a negative argument in a logarithmic function. If I plug in 3 for x, I will have the log of 5 plus the log of 2. That's good. If I plug in negative 4, I will have the log of negative 2 plus the log of negative 5. That is not okay. Not okay. That makes no sense at all. So I have to throw out that second answer, and I'll have x equals 3 as my solution. All right. I'm going to have you do D on your own, as well as E, and go ahead and do G and H too. But for now, I will go through F for you. And it's very much like the one we just did, except that I need to isolate my logs on one side this time. They're not all moved over for me. So first, I'm going to condense my left side to a single log. X times x plus 1 equals the log of 12. So that's the log of x squared plus x minus the log of 12 equals 0. Subtracting logs, I can condense this again and turn it into division. The log of x squared plus x over 12 equals 0. I have an invisible 10 here as my base. So I can write this as 10 to the 0 power equals x squared plus x over 12. 10 to the 0 power, let me finish this down here. 10 to the 0 power is 1. Multiply both sides by 12. Subtract 12 from both sides. And then factor. Hey, this looks very familiar, doesn't it? Almost like we just did this. So x equals 3 and negative 4. But again, I need to check. Do not, I repeat, do not forget to check. This is vital. So plug in 3. I'll get log of 3 plus the log of 4 equals log of 12. That's fine. Plug in negative 4. I have the log of negative 4 plus the log of negative 3. That's not okay. I have to throw out negative 4 again. And my solution is x equals 3. All right. That's it for this section. This video went a little longer than I had hoped, but there was also kind of a lot to cover. So we will do plenty of practice with this in class. For now, go back over sections that confused you, sections that you missed, and then make sure to do some of this practice on your own so that you're all set and comfortable once we do this in class together. All right. Hope you have a good day. Thank you so much.